Welcome to Space Nuts. My name is Heidi Campo, and I'm here with Fred Watson, astronomer at large. And I bet many of you are wondering, who is this lady? Why is she here? Where is Andrew? I can assure you he is just fine and probably having the time of his life. I am here filling in, helping him out while he is on a little break. And I found Say Space Nuts originally from just being a listener myself. I also have a podcast, Reality Check, The Science of Fiction, where I talk to subject matter experts about the plausibility of sci-fi concepts. And I am a graduate student here in Space City, Houston, Texas. And I'm focusing on spaceflight, human optimization, and performance. So I have a very interesting segue into the space world. I'm really interested in a lot of the sci-fi concepts that integrate into space science and all the new discoveries that Fred knows so much about. And I'm excited to be here as your fill-in host for this episode.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Fred, thanks for having me.
You're very welcome, Heidi. It's a delight to welcome you to the Space Nuts team. It's very appropriate, I think, that we should be beaming out from Houston, Texas. And what better person to fit into Andrew's empty shoes at the moment than yourself? It's lovely to have you, and I'm really looking forward to our next few sessions when we can chat together behind Andrew's back.
No, this is going to be great. So we have some really interesting topics this week. I was looking over them. We're going to be talking about the Blue Ghost sojourn on on the moon. And that looked really interesting to me. The other thing we're going to be talking about is some of the activity with the James Webb Telescope about Neptune. So that's a planet we really don't talk as much about. Neptune is really kind of the ignored stepchild of the solar system. So I'm excited to hear what you have to say about that activity. And then the last thing we'll be talking about today is the Helix Nebula and some really exciting new discoveries going on with that. So I think that I would be interested in just jumping right in with the Neptune story.
Excellent. A good planet to start with, Heidi. And you're absolutely right. Neptune has only been visited once by a human-built spacecraft. Maybe there were alien spacecraft that have visited it, but only one human-built one, which was Voyager 2. So what we know about it really comes very much from the images that were taken when Voyager 2 flew by Neptune. That was in the 80s. But Neptune, of course, is a world that has an active atmosphere. It's an ice giant, one of the two ice giants in the outer solar system. And that term refers to the fact that we believe there are solid ices as a kind of haze in the atmosphere of Neptune. So it's slightly different from the other two gas giants, Jupiter and Saturn, which are they don't have those icy hazes because their temperature is just slightly warmer, being nearer the sun. So the really interesting thing was when the flyby with Voyager 2 took place, Neptune looked very boring. It had, it was just like a pale blue-green disk with not much happening. And I think that probably did it a disservice because we thought of this planet as having rather uninteresting atmospherics. Although subsequent measurements made from Earth actually demonstrated that it does have high winds in its atmosphere. And just a mention to the system of moons of Neptune, because some of those are particularly interesting as well. Triton is its largest moon. It may well be one of these ice worlds with a rocky core, an overlying ocean, a global ocean, and ice on top. But that's not what we're talking about today. So what's the story? Why is Neptune in the news? Well, it's because, as you might expect, it has been a subject of observation by basically astronomy's new toy, still new, after 3 years, I guess now, the James Webb Space Telescope, with its marvelous infrared cameras and very, very sensitive spectroscopic systems. So what has been detected by the Webb is something that we've known about, maybe hinted at by earlier observations over a long period of time, probably since the Voyager flyby, that it has aurorae, or auroras, if you want to be less picky about your Latin, aurorae, northern and southern lights, like we have on Earth, like the other gas giants themselves have. But the problem is, hints are fine, but what you really want is a kind of signature of these things in the spectrum, the sort of rainbow of colors that we see when we split the light up into those components. And that, as we've discussed many times on Space Nuts, those spectra are crossed by a kind of almost like a supermarket barcode of information, which we can read and detect what gases are involved with these spectral colors. So, yes, the James Webb has thrown its might behind observations of Neptune, and sure enough, we have found strong emission of the kind of telltale elements that indicate auroral activity. And remember, aurorae are caused by the solar particles, the subatomic particles that come from the sun interacting with the atmosphere of a planet. That's what causes the glow. And that's why it has characteristic colors, because the glow itself comes from the elements in the atmosphere. So yes, aurorae on Neptune, and very similar to the phenomenon on Earth, but different colors because it's different elements that are being excited. The green in aurorae here on Earth comes from oxygen, which isn't there on Neptune. So
Right.
the colors they're actually coming from hydrogen.
Yeah, and it's absolutely beautiful. I'm looking at these images right now. It reminds me of one of those mood rings that were really popular in the 90s where it starts to change
Yes.
color. It's really spectacular to see. And I'm seeing in this image, so you just described that the greenish color comes from hydrogen. I'm seeing also spots of white, because if you look at the images of Hubble, which it's pretty much just blue all the way across, and then the
Yeah.
image of the Webb, there's some big white spots. Is that part of the aura?
I suspect some of those are clouds, which are also now visible in the infrared. We see similar things in the atmosphere of Uranus, white spots, which are very extensive areas of cloud in the atmosphere. The atmospheric circulation, on both those ice giants, Uranus and Neptune, is relatively slow in terms of the changes in the atmosphere, and that's partly because the temperature there is minus 214 degrees Celsius at the surface. But that doesn't necessarily mean that you don't get high winds. And in fact, I think the winds on Neptune are the record-breaking winds in the atmosphere of a planet in the solar system, up to 2,400 kilometers per hour. What's that? That's about 1,800 miles per hour. So
That's very fast. I'm thinking of it in hurricane terms.
yeah, it's super hurricane. That's right. And I think that there is also on Neptune, there is something that's sort of related to the Great Red Spot on Jupiter, a storm, a long-lived storm, and maybe that's what's showing up as some of the white spots, or at least one of the white spots. I'm just looking for them now. There is a big white spot in the middle of the JWST images,
And it
but I
looks like
think the
there's some on
greenish
the poles.
is the aurora. And you've just reminded me, though, looking at those pictures, one of the peculiarities of Neptune is that we think its magnetic axis, the two magnetic poles, are tilted well over to sort of mid-latitudes, unlike here on Earth, where they don't exactly align. Magnetic north is not the same as geographic north, but the magnetic poles more or less align with the rotation of the planet. And that's probably to do with the fact that we think that the Earth's magnetism is generated by the circulation of the iron and nickel core, which is in two parts, and it sort of acts like a dynamo, and that generates a magnetic field. Neptune and probably the other gas giants have something similar. We really don't understand the origin of their magnetism. We don't know whether there's a solid core or not in the gas giants. We suspect there must be in order for them to have these strong magnetic fields. But on Neptune, the magnetic field is tilted over at quite a considerable angle to the rotation of the planet, which is why the aurorae appear at mid-latitudes on Neptune rather than near the poles as they do here on Earth, as I know well from my sojourn up in the Arctic 2 months ago.
Yeah. So I've heard there's something going on with Neptune's orbit. It's either wobbly or it changes or something like that. Would that have anything to do with this tilt?
It is possible. The two may be related. Usually, the rotation of a planet and its orbit are fairly decoupled, and you've only to look at Uranus, which, as you know, is tilted
Sideways.
over 9 degrees. I think it's 9 degrees below the what you might call the horizontal, the plane of its orbit. And Uranus has a reasonably sort of well-behaved orbit. Neptune's interesting because it's in modern parlance it represents the outermost planet of the solar system, and it does affect the orbits of the many myriads of objects that we know lie beyond that, the so-called trans-Neptunian objects, which include things in the Kuiper Belt and things called resonant objects like Pluto's. Pluto's a resonant object because it resonates in its orbital period with Neptune, and the scattered disk objects, as they're called, way beyond that. So it could be that Neptune's orbit is interacting with those. Although a big planet like Neptune, it takes a lot to shift its orbit to perturb it. So I haven't seen those reports that you mentioned, and everything you've just heard is complete waffle, but that's the way it works when you're talking about things you've not seen before.
Right. And I think there's just so much of that with space. It's I was at a NASA Tech Talk last week, and they were talking about SANS, which is an ocular syndrome that the astronauts experience.
Yes,
where
I've heard
they
of it.
have issues with their eyes. And for those of you listening, my little dog's begging for attention in the corner. We're just going to ignore him until
there you go.
playtime when we're done recording. But the presenter, he was a flight surgeon, and he brought up so many funny headlines and articles. It's NASA scientists say this and this. He's like, I cannot find these experts.
Yes.
If anybody knows these experts that this headline is claiming to talk about, please let me know, because this is all wrong.
Yeah.
So I think there's a lot of that in the space industry.
So that's a really interesting syndrome, isn't it? Because that's one of the potential long-lived consequences of long-term spaceflight, that you've got these ocular effects. Sorry, we're way off topic here, Heidi, but that's all right. Hello, I've forgotten your dog's name.
Simba, like the Lion King. He's wagging his tail. He's trying as hard as he can to be as cute as possible.
He's doing a fine job.
Yeah,
the tail wagging's always
cuter.
Good.
He thinks if he's cuter, I'll stop recording and go play with him.
Yeah, I know the syndrome. So what I've read is that it may be caused by the fact that, the circulation in the body, the blood circulation in the body changes in microgravity, and that you might well have pressures in the cranium that might affect the eyes in a way that we don't have on Earth. Is that the thinking, or am I just making that up?
You're absolutely spot on. Yeah, it has everything to do with fluid. So when the fluid changes in the body, we normally have gravity pulling that fluid away from the head. But when we're in space, the fluid tends to, pool up towards our head and shift in places that we don't necessarily want it. So that is a leading issue in causing that pressure. And then there were there are so many other points and tangents with that, but we're learning so much more about it now. And one of the really interesting things with space medicine and human performance in space is when we're looking at the research, we'll have like an N of 8. And for those of you
Yes.
non-science people, N is your subject number. So, when we're looking at, cancer research, that can be in the hundreds or thousands of data points that we're looking at. But when we're talking about astronaut health, it's just a handful of people. So there's as much as we know about it is with the people that have been to space already. And that's one reason why I'm so excited about what some of these other companies are doing, like Blue Origin, Axiom, Virgin, that are getting more and more people into space so that we can learn more about space health, which does influence health on Earth. There's so much we've learned about space medicine that has helped improve life on Earth.
Which is remarkable and great news, and one of the the many benefits of space exploration. We've got another commercial flight about to launch, I think, within the next few days. Is that right? The Fram 2 mission.
Oh, they are going all the time. I can't even keep up with all of them sometimes.
Yeah,
that's what you should listen to this show for.
Yeah.
So I have another Neptune question, and I want to segue this in with the humans and the people part.
I love that.
Are you familiar with the book? It's a book and a TV series called The Expanse. Are you familiar with it?
No. And I apologize for that because
okay.
I there's so much going on out there that I simply don't have time to read or look at. And
understand.
I certainly rely on Andrew keeping me honest in regards to science fiction, and I'm sure the same is going to be true with you. But no, I don't know about The Expanse.
So in The Expanse, they have populated the solar system. There's people living on Earth, Mars, and there are also people living out in the asteroid belts. They call them belters, and these people are multi-generations born in space. So they have physiologically adapted to life in space. So they have become physically different from people born on Earth because of the gravities and the systems there. So I want to segue this back into talking about Neptune, because we have ice, we have wind. And from what I do know about greenhouse gases, and thinking about The Expanse, there has been some chatter about putting some industrial factories and whatnot on Mars eventually to help generate greenhouse gases to help increase atmosphere on Mars. Is this something, because I always like to think about what we're looking at and seeing with these auroras in space and everything we're learning, and what does it mean for future generations? Could Neptune potentially be a big power generating planet with these winds, if we could harvest these winds?
What
and
a lovely
ice.
idea. Wind turbines on Neptune. Now that's a really expansive idea, if I can use the joke there. The likelihood is that with so many things that people talk about doing in space, it's actually easier not to. To find alternative sources of whatever it is you're trying to generate. And the winds on Neptune, colossal winds, as we've said, up to maybe approaching 2,000 miles per hour. How you would generate them, it's hard to know. What might be interesting, though, is if you could use them. How you could use those winds to generate power. It's hard to know. But if you could use those winds to facilitate exploration of the planet's atmosphere, and that's something I could well imagine, people dropping balloons into the atmosphere of Neptune to watch the circulation, to do what we do here on Earth with our multiple capacity for measuring and predicting the weather. So weather on Neptune might be something that turns out to be quite interesting. I think in some ways, a more what's the word? Apposite, maybe is the right word. World to be interested in the Neptune system is moon Triton. because that could turn out to be, one of the places like Europa and Enceladus that has the potential for perhaps living organisms beneath the surface. And that is very exciting.
Very exciting. And it really just comes down to the human ingenuity, the engineering, and all the new breakthroughs that we're making. It seems like every single day there's more stuff that we're coming up with to get us out there.
Okay, let's take a quick break from the show to give a shout out to our sponsor, NordVPN. Now, if you're not familiar with VPN or virtual private networks, think of it like a shield that protects you from hackers and scammers trying to hijack your data. It keeps you hidden online, which is super handy anytime you're using public Wi-Fi, and that could be at airports, railway stations, hotels, cafes, shopping malls, basically anywhere that offers open, unencrypted Wi-Fi. Getting hacked and having your personal information stolen, or worse, sold on the dark web isn't fun, but it's avoidable with a VPN. And honestly, there's no better option out there than NordVPN. Right now, Space Nuts listeners get an exclusive deal, 4 months extra for free when you sign up for a 2-year plan. And that's a saving of 74%. Plus, it comes with their 30-day money-back guarantee. All you have to do is head over to NordVPN/SpaceNuts and click on Get NordVPN. You'll see all the current deals and options, including their VPN service, malware protection, ad blocker, tracker blocker, their awesome password manager, and even a data breach scanner. Seriously, have a look at it. NordVPN.com/SpaceNuts. I've been using Nord for over 2 years now, and I'll be renewing because it's hands down the best security for my needs, and probably for yours too. NordVPN.com/SpaceNuts. All right, let's get back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Which I think is kind of a good segue into our next story. So NASA's created this new dust shield, and it's going to help repel the lunar regolith, which is very important. The regolith is very fine. It's very sticky. It can be kind of dangerous if this is getting in their analogs and their facilities and where they're living. So tell me more about this. This is quite the interesting story.
That's Geordie. Let me just check what's happening, because it's
he does sound like a chicken.
Yeah, Geordie. I do apologize.
He did sound like a chicken.
He does, doesn't he? Yeah, it's just like a rooster. He doesn't know that. He thinks he sounds like a big. Yeah, just calm down, Geordie. It's all right. There's a dog that he hates, that its owner occasionally brings it near our property to take it for a walk.
Don't they know better?
Yeah. All right, Geordie, calm down. Good boy. Okay, so the lunar regolith. Back to the moon, from the sublime to the ridiculous, or the other way around. Yes, you're absolutely right. The soil on the moon is such an interesting thing. It's different from anything we have on Earth, and that's because it has been formed not by wind and water erosion like the soil on Earth has, but by bombardment by these subatomic particles, the wind of particles that constantly blows from the sun, probably a few micrometeorites banging into the surface as well. And so what we've got is a soil that is very, very fine and very angular. So it's got sharp edges all the way around it. And exactly as you've said, that's why it gets into all the nooks and crannies, all the crevices, basically the clothing of astronauts. There is one recorded case, and you probably know more about this than I do, Heidi. One of the Apollo missions, and I can't remember which one it was, but so much dust was brought into the lunar module by one of the astronauts that it pervaded the whole return trip back to Earth and gave that person the first case of lunar hay fever because he was sneezing all the time because of this dust. I can't remember who it was.
I do remember hearing about this, and I also can't remember who it was. But yeah, it can be quite the problem. It's just this sticky, fine mess.
So NASA, in their wisdom, are looking at ways to mitigate the effects of that. And as part of the Blue Ghost mission, that was spacecraft, a commercial spacecraft, landed on the moon successfully. I don't know, a month ago, I guess. It's not very long ago. Which was part of NASA's program for, I think it's called the Commercial Lunar Payloads Program. In other words, getting the commercial world to actually do some of the legwork in preparing for the Artemis flights to the moon later in the decade. And one of the experiments carried on board Blue Ghost was indeed about how you can reduce the effects of this lunar dust. It has a name. It is called the EDS, the Electrodynamic Dust Shield. And basically, it is a way of removing the contamination of dust and dirt from whatever surfaces you've got on the moon. Probably it's more like spacecraft surfaces than clothing, although it might lend itself to that eventually. And it seems to have worked very, very well. There is a pair of images which are pretty easy to find on the web. I'm looking actually at the NASA website itself for the press release, which is entitled "NASA's Dust Shield Successfully Repels Lunar Regolith on the Moon," and you can see a before and after with this device activated. I suspect it works. Well, it's called an electrodynamic dust shield, but that electrodynamic usually means moving electrons, so there's a current flowing. But I suspect that the basic mechanism is electrostatic. It's a repulsion of the slightly charged soil particles that exist on the moon. They are electrically charged. So if you can give them an opposite charge, they'll be repelled. And that looks as though it's what's happening, and it's been met with success. So perhaps it's a step forward in cleaning up our voyages to the moon and not bringing back a whole lot of unwanted moon dust when you come back to Earth.
Absolutely. And I'm just thinking again of the implications for Earth, because I think sometimes there's a little bit of, like I said earlier, there's a little bit of a disconnect, thinking space and how it's not related to Earth. And it's so related to everything we do here on Earth. I mean, GPS.
Yep,
NASA gave
absolutely.
us GPS. NASA gave us water purification. NASA gave us, oh man, I'm totally mind blanking. The big machine that you go into that scans you if you go to the hospital.
Yeah, an MRI.
MRI machine.
Yeah.
Yes, that should be the one that I know. But yeah, I mean, so much of this has come from space science. And I'm thinking of something that would make my life easier, even just on the simplest level, if the surfaces in my house, my tables and everything repelled dust.
Wouldn't
And
that be
I
awesome?
don't know if we are just that much closer to inventing dust repelling surfaces. And that just makes everybody's life that much easier, that much safer, because then you're not using cleaning agents and chemicals to clean your house. You just have a surface that just repels that dust automatically. And that could even have really good implications in sterile environments like computer, places where they're building computer or hospital settings. So this is actually very, very exciting that they're doing this. And the article is quite short. It's just a blurb, but the implications of this, we don't know how this is going to improve life down the road.
Exactly. That's right. It's, the sky. Well, the sky's the limit, really, isn't it? In terms of what we can do with space technology, technology perfected for space. I do worry, if you press a button and all the dust leaps off all the surfaces in your house, you might need an extractor fan to take them away so they don't wind up somewhere where you don't want them.
Yes,
like
that'll
in
be
your lungs.
the next segue.
Okay, we checked all 4 systems and keying was a go.
Space Nuts.
Yeah.
Speaking of the sky being the limit, our last article that we're looking at, there was a big nebula explosion, and there's a glow left over from it. The title is "A Nebula's X-ray Glow May Come from a Destroyed Giant Planet." And that's quite dramatic, but we are excited about these images because it tells us about history.
Yeah, that's right. And in fact, everything in the universe tells you about history, which is great because you're always looking back in time. We're looking back in this case, I think it's about 650 light years. It's a very, very well-known object called the Helix Nebula. And in fact, first captured in full color by my colleague and friend David Merlin, who was the person who essentially developed a technique in the 1970s and 80s to put true color into celestial images by taking 3 sets of photographic plates, as we used in those days, through red, green, and blue filters. And he became very well known for that. He was totally fastidious, and still is, actually, about getting the color balance right so that what we saw in these images was what we would be able to see if our eyes were millions of times more sensitive. Now, segue from that to the present time, when that lovely color image of the Helix Nebula, it became very, very famous. That was what we see in visible light, but it's now been observed at many other wavelengths of light as well, and ranging from infrared to X-rays, if I can put it that way around, or X-rays to infrared. And it's the X-ray radiation that is the most exciting, and it's the reason why we've got this story. So the Helix Nebula, just to give the backstory, is what we call a planetary nebula. And it's nothing to do with planets, except in the way that we'll come to in a minute. It was called that by William Herschel, an astronomer back in the early 19th century, who saw these things, which were clearly not planets because they were in the deep sky. They were moving with the stars rather than with planets, so they weren't in the solar system. But they had a slightly planetary appearance. They looked circular. So he called them planetary nebulae. And what we discovered in the early 20th century is that what we're seeing there is the outer layers of a star which has reached old age and is not massive enough to explode like a supernova, an exploding star that detonates and blows itself to pieces. You need to be more than about 3 or 4 times the mass of the sun to do that. In fact, 10 times is probably a better bet. The star, like the sun, gets to the end of its life, and basically the instabilities that are caused by the fact that it's used up most of its hydrogen fuel, it causes the outer atmosphere to basically to be shed gently, and that produces a cloud of gas, often spherical in form. Sometimes they're hourglass shaped. They've got all kinds of different shapes. But the Helix Nebula in the southern hemisphere sky is the classic example of a planetary nebula. A star at the end of its life, it's shed its outer layers. They're glowing because what's left of the star is a remnant called a white dwarf, which is an object the size of our planet, size of the Earth, but with the mass of a star. So it's very, very dense. Now, white dwarfs are interesting creatures in their own right, but the Helix Nebula has one that is even more interesting than normal, because it radiates copiously in X-rays. And X-rays we have to get above the Earth's atmosphere to detect, because the atmosphere, fortunately, absorbs X-rays very, very effectively. But there have been a number of space satellites, mostly satellites around the Earth, spacecraft that have been essentially used to survey the sky in X-ray emission. And the Helix Nebula, of course, has been one of the things that have been looked at with X-rays, with a whole series of different satellites through the ages. It was actually first detected back in the early 1980s by NASA's Einstein Observatory, which is an X-ray satellite. And there was another one called ROSAT. I guess it comes from Röntgen, the German word for X-rays, after Herr Professor Röntgen, who discovered them. ROSAT in the early 1990s. Both of those spacecraft detected X-rays from the Helix Nebula, which weren't really understood. Now, those have been followed up couple of decades later, NASA's Chandra X-ray Observatory in 1999 and XMM Newton, which is a European Space Agency spacecraft, in 2002, have recorded these copious quantities of X-rays coming from the Helix Nebula. What is it all about? Where do they come from? How do you get something that shouldn't be producing X-rays but has sort of 30 years, 20 years anyway, of strong X-ray emission? And so the people who think deeply about these things, the theoretical astronomers, and some of these astronomers in this case, some are in the United States, but some are also in Mexico, they have deduced that what's happening is probably a Jupiter-sized planet, maybe a bit more than Jupiter, was orbiting the star as it reached the end of its life, carried on orbiting the white dwarf, but because of the forces involved with the collapse of the star to a white dwarf at the end of its life, the planet was shredded, basically, and formed a ring of a disk of material. Not a ring of disk, that doesn't make sense. A disk of material around the white dwarf, which is accelerated to very, very high velocities. The gravitational field of a white dwarf is a bit like a black hole, not quite as extreme, but very strong. And so
this is the ghost of a planet.
Exactly. Yes, the debris of a planet, planetary ghost. I love the term. It's its dismembered remains are whizzing around this white dwarf at high orbital velocity. And that creates X-rays because of the heating effect of this turbulence that is in the disk of material. And that's the theory at the moment, and it's the best one that we've got, as to why the Helix Nebula is so copiously emitting X-rays, that it's got an unfortunate planet that didn't survive the collapse and is radiating violently in the X-ray wavelength. So, rather intriguing story.
Let me see if I understand this correctly. So I'm looking at this image, and it's got kind of a red dot in the middle for those listening. If you don't see the image, you guys can look up the Helix Nebula. It's a very famous photo, and you'll see what I'm describing. It almost looks like kind of like an eye. Yes. So it's got this red, like the Terminator. It's got this red dot in the middle, and then it almost looks like an iris, and then it keeps expanding out. It actually does look exactly like an eye now that I look at it. But so the planet got sucked into the red, which is the dwarf, and then spun apart like a centrifuge. And because it looks like it exploded from inside out, but what's happening is it's spinning apart, and that's why it's surrounding this red. And it's spinning, and so the gravity is like the debris coming apart from the center rather than getting pulled into the center. Is that what am I understanding this correctly?
Yeah, that's right. Yes, okay. That's right. So the X radiation is it's sort of pervading the whole of the nebula. You've got X-rays coming from every part of it, or appearing to, but they're being emitted by this object, which is actually within, it's not visible. The disk itself is not visible. The disk of material that was this planet, that's too near the white dwarf. The white dwarf itself is visible in optical images, visible light images, but not in the X-ray image. So it's a matter of inference along the lines that you've just described, Heidi.
So maybe you already explained this, because this doesn't make sense to me. Why? So if the gravity's strong enough to be keeping these bits and parts within its gravity, why is it still spreading out?
So the gaseous envelope of the star itself was basically emitted over many millions, probably tens of millions, hundreds of millions of years before the star collapsed into a white dwarf. So that's far enough away that it's not feeling that intense gravity in the region near to the white dwarf itself. It's basically drifting off because the distances are measured in light years. They're not measured in millions of kilometers. They're very, very large distances. So Yes, it's a great question, though. So it's all the stuff that is really within the immediate vicinity of the white dwarf that's feeling that acceleration and undergoing that intense orbital motion around the white dwarf.
Is this your favorite nebula?
It probably is, actually. That's a really good question, too, because I've never sort of thought about that. There is a well-known one in the northern sky, which will be visible from Houston, called the Ring Nebula. But the Helix Nebula, I think, is a little bit more glamorous because it's got a bit more structure to it. It's got this. It's called the Helix Nebula because it looks a bit like a sort of unwound spring. And you can see you're probably having a look at the Ring Nebula as we speak.
I am
Is that
looking
right?
it up. Oh, it's absolutely beautiful. That's just stunning. So I think maybe this will be a topic for a Q&A or another session, but I definitely want to understand more of the technology that you said your friend developed. His name was also Fred?
No, David. Actually, is Fred. His middle name's Frederick.
Frederick, okay.
David Malin, yeah. So he just briefly, when the Anglo-Australian telescope, it's the largest visible light telescope on Australian soil, with a 3.9 meter, 156-inch mirror. And he and I both worked there. I was the astronomer in charge for 20 years, in fact. But before that, in fact, when the telescope was brand new, he was taken on board on the staff. He speaks a lot like me because he comes from the north of England, went to Australia and perfected this technique. In those days, imaging of astronomical objects was done with photographic plates. And I'm talking about 1975. That's when he went to Australia. Apart from a few experiments with color emulsions, normal color film, which really didn't work well for astronomical objects because color film is designed for a very short exposure. You're in a camera, you press a button, shutter opens and closes again in a 50th of a second, and you record the image. Astronomers spend hours exposing their photographic plates, as we did in those days. And the whole, optical chemical process that makes color photography just didn't work. And so he designed this technique. It actually goes back a couple of hundred years to the way people thought you can perhaps replicate with the red, green and blue, you can replicate a color image. And it's true, you can. But it took David's skills and hard work to perfect that. And the result was twofold. It made the telescope very famous because his images found their way onto the front covers of magazines and album covers and books. They were all over the world in the 1980s, early 1980s. It made the telescope famous and it made him very famous as well. And he still is interested in this. He's now retired. He doesn't really do any frontline photography anymore, but occasionally we end up involved in scientific discussions about all kinds of things. So he's still very active.
Well, I think nebulas, are probably one of the most beautiful things in space. And these images are just breathtaking. And to think of it's almost impossible to comprehend the scale of a nebula because we just see them on our desktop as a beautiful picture. But to think of the size and the magnitude is quite amazing. And the contributions to the field are really quite incredible. It's quite astonishing to think of the conspiracy theorists and how they think that these are just computer generated images. And they're like, oh, the scientists are just painting the photos to make them look like how they want. And then you're telling us stories of how your friend and you put 20 years into just developing these technologies.
Yeah. Yeah, that's right. Look, conspiracy theories are another breed. We can talk endlessly about them. But yes, the work that David did was really very rigorous to try and make sure that what we were seeing was what we would see if our eyes were more sensitive. The downside of that, Heidi, is that whenever David went anywhere to give a talk, and he did that all the time, especially in the digital era, as things moved on, he got very upset if the color balance on the projector was not to his liking. And indeed, he started all his talks, and I do now, with a basically a color chart, a color diagram. And if it wasn't to his liking, he would start tinkering with the projector to try and make it so. And once in a while, he would refuse to give the talk because it would not show his pictures in the true colors that he'd worked so hard to create.
Wow.
Yeah.
Talk about a perfectionist.
Yes.
And it's things like that, you really just makes the conspiracy theorists sound just that much more silly. They think they have something figured out because they watched a YouTube video.
Yes,
But
there you go.
not to end on a negative note with the conspiracy theorists, and we'll take it as we're ending on a positive, talking about these beautiful, beautiful nebulas and these incredible contributions to the field. Yep. And I just want to, I don't know, inspire and encourage listeners to, if you're a space enthusiast, to keep considering all these possibilities. And if you are someone who works in the field, you never know what, you're going to be producing 20 years from now, and what your work is going to do and contribute to humanity, and what kind of neuroticism you'll develop if you'll never be able to look at a projector the same way, or if you're just going to become the person who is so obsessed with doing this one thing because you've put 20, 30, 40 years into studying something so incredibly niche. Fred, do you have anything else you want to add?
Not to that story. Just to say this has been a wonderful session. I think it's episode 509 that we've just done.
Wow.
It's been great talking to you, Heidi, and I look forward to our next chat.
Excellent. Again, thank you so much for having me, and you have been listening to Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.